Hi there. So this tutorial is going to be about joining tables in Tableau. The purpose of this tutorial is both to understand the basic reasoning and rationale, and also to understand the difference between an inner, a left, and a right, and a full outer join. We're going to use a toy dataset first, and then you'll go ahead and use the UN population divisions dataset. This is the same dataset that you used in the last tutorial, but this time we're going to join a little bit more information to this. All right, so the reason that we use joins is to connect separate tables of data that share a common variable. So the way that this works, there has to be some sort of unique identifier for our tables to join on. That can be a name or that can be a unique ID. It just has to be something that our tables can join this information on. The purpose of this is so that you can really keep data separated and maintain multiple smaller tables without having to maintain one big giant table with all the information about everything. So first, I'm going to have you go ahead and watch this video from Tableau, and then we're going to come back and apply those principles to a small person, children, and education data set here. All right, enjoy.
Welcome to this video on join types. Depending on your data source, Tableau Desktop offers several options for joins, including inner, left, right, and full outer joins. But what do the various join types mean? Joining tables is a way of combining information, that is, new fields or columns, from multiple tables based on a field they share. Joins are always made on a specific field or fields. Here at the top, we have two tables we want to combine. The table on the left contains sibling information, and the table on the right contains eye color information. We'll join these tables on the field they share, name. An inner join preserves only the rows that have the same key field, in our case name, between both tables. We only get information for names that are listed in both tables, and there are no nulls. A left join brings in all the information for the rows from the table on the left, siblings, and any information from the table on the right, eye color, for rows with the same name as the siblings table. Therefore, we get all the information from the left siblings table, and for the names that are also listed in the right eye color table, Taylor and Alex, we also get their eye color. If a name from the siblings table is not present in the eye color table, we get a null, such as for Shannon and Tracy. Let's see what this looks like in Tableau. As you can see, a left join pulls in all the rows for the table on the left and fills in from the table on the right when it can, with a null if that name is not present in the table on the right. In a right join, it's the reverse. We have all the names from the right eye color table, and for those rows, we get the sibling information if it exists. As you can see, the output list of names varies between the left and right join because we're changing which table comes first. Shannon and Tracy do not exist in the eye color table, so they show up in the left join only. Morgan doesn't exist in the left table, so she shows up only in the right join. An outer join brings in all names listed in all tables and fills in nulls wherever there isn't information for a given column or row. That's a quick primer on join types. As a reminder, not all joins are supported by all data sources. Although unions are not technically joins, it's worth mentioning them in this video. Unions are another way of bringing together two or more tables. While joins can be thought of as horizontal, adding columns to an existing table, union can be thought of as vertical, adding rows to an existing table. Note that union can be performed on specific files brought into the data source page, or by a wildcard search through the directory. Tableau follows the behavior of union all. That is, all rows will be returned in the union even if there are duplicate values for some rows, such as here for Kai. In Tableau, new fields are generated with the table name, which indicates metadata about the union's source. Finally, it's worth noting that if the field names don't match across the union data sources, Tableau will function similarly to an outer join, appending the new rows and the new columns, with nulls as needed. If the new columns should be considered the same field, the columns can be merged in the data grid. For more information on data connections in Tableau, check out the other videos in the Connecting to Data series.
All right, welcome back. We're going to get started in Tableau by going to connect a Microsoft Excel sheet or workbook. We have the children and occupation dataset that's linked on the course website. If you don't have access to this, go back to the course website and follow that link. So we will load that in, and we're first going to do an inner join. All right, and an inner join is when the records exist in both tables. So it keeps only the records that appear in both of the tables. So we'll first pull over our occupation table. And we see with our occupation that we have Wanda, Floyd, Clyde twice, and Betty. Wanda is a chemist, Floyd is a scientist, Clyde is an engineer. He is also a data analyst, and Betty is a data analyst as well. All right, so that's what our occupation table looks like. Let's look at our children table. Looks like our children table has Wanda, who has two children, Maria and Lacey. Floyd has Marcus, Clyde has Luella, and Vincent has Valentino. And then we have the ages of the children over here. You might notice that Betty is missing from this table. Maybe we don't know how many children she has. Maybe we don't know whether or not she has children. This is actually kind of a poor data quality thing because it would be more informative to have Betty in this table and then say NA for child and NA for age if we knew that she didn't have any children. If we didn't know, we'd also want to indicate that somehow. And the same is true for occupations. But anyhow, the fact that these are constructed like this really helps us out because Vincent appears in the children table. Betty appears in the occupation table. We'll just keep that in the back of our mind for a minute. All right, let's pull the children back over here. Now we're going to start with occupation, and then we're going to join our children table to it. And by default, Tableau uses an inner join. And this is for a variety of reasons, the most of which is that since an inner join keeps only what appears in both tables, it's actually the most restrictive type of join. And therefore, in some ways, the safest. All right, so you might notice down here that nothing appeared. We don't have any data joined together. That's a little bit odd. There's a couple of clues here about why that might be. Let's go ahead and click on the circle, and we see why. So we have age in our occupations table, but we also have age in our children's table. Again, this is poor data structuring, but it's not too hard to deal with it. So we just go in and click and tell Tableau, hey, don't use age, use first name. That's actually what the common column is here between these two data tables. All right, so we have completed our inner join, and Tableau down here has said, great, I've found everyone who's in both tables. Tableau found Wanda, Floyd, and Clyde. Tableau says, now since Betty doesn't appear in the children table and Vincent doesn't appear in the occupation table, they don't belong in this inner join because they don't overlap. Let's go ahead and change this, and we'll take a look at left join now. We'll go ahead, click on our two circles here, and click on left join, and let's go and inspect what happened. All right, it looks like we have Wanda, Floyd, Clyde, and Betty. How did Betty get in here? Well, Betty appeared because she does exist in the occupation table, even though she doesn't exist in the children table. And everywhere that there would have been Betty's information, there's a null value put in place. All right. Now you might be thinking, great, let's go check out a right join. Okay. And the exact opposite thing happens. We have Wanda, Floyd, and Clyde. And now, instead of Betty, who has disappeared because she doesn't appear in the children table, we have Vincent, who is in the children table, right? And then we have null values for his education or occupation because we don't know them, right? One last type of join, and that's the full outer join. And you see here, everyone in either table appears. So we have Wanda, Floyd, and Clyde. We also have Vincent, who's in the children table, and Betty, who's in the occupation table. And this allows us to bring in all of the data that we have and just fill in null values where we don't have data about that individual. All right, now let's go back and take a look at some of how this all went down. I'm going to go back to our inner join. If we look here at our inner join, we might notice that Clyde and Luella has been duplicated. Whenever there are two unique records, Tableau will duplicate whatever it needs to in order to make completely unique records in the join. So it won't automatically drop anything for you. All right, now let's go back to the left join. We see that the left join is positional based on how you loaded your data sheets. So because we loaded occupation first, it is treated as the primary data sheet, whereas children is the secondary and gets joined too. Now, if children was on the other side and occupation was over here, then a left join would be our current right join. If that has confused you, don't worry too much. More importantly is that you usually do left joins and you almost never do a right join, because if you were doing a right join, your primary table would probably be on the left. So it would be very odd to do a right join. All right. Full joins are very, very common. And it's really when you want to preserve all of the data that you have, even if that means creating null values. All right. So that is kind of the overview of how to do joins. Now let's go ahead and put that into more practical action. Navigate back to the UN population download page, and this time select CSV format. This is linked in the tutorial. It's also the same page that we got the UN population data from for the last tutorial. But this time we're going to use a CSV format. And you'll notice here that there's actually instructions. The instructions are particularly for R, but they work just the exact same way for Tableau. So these CSV files are encoded in UTF-8, and every single one of the files has the following columns. It has the location ID, which is a numeric code for the location, and for countries and areas it follows like a standard. The location string, which is the name of the region, the variant string, the time, and the mid-period of the data. Now, this is really important because most well-developed data sets will have a numerically based or an alphanumeric identifier that's unique for each record. In this case, it's the location ID. And the reason that that is more useful is that humans are really bad at spelling. And many, many countries in the world, particularly countries where languages that do not have a Roman alphabet are spoken, such as any Arabic-speaking country, the transliteration, so the romanization of the country name, is not always the same. So a lot of times it's way better to have an alphanumeric code. All right, so for our purposes, we are going to download the population medium variant and the period indicators medium variant. This will allow us to ask questions about the relationship between population and fertility and the number of births and things like this, which will help us make better sense of the overall population trends. All right, so we'll head back to Tableau and we're going to connect our data as a text file. Quick word of warning, this is going to be much easier on you if you save both of the files you just downloaded into the same folder. Ideally with nothing else in that folder. I've called mine UN population data or something like this, UN indicators. It's just going to be much easier for you all around. All right, I'm going to choose the population by sex and I'll pull that in, and you see that because I saved them into the same folder together and they were the only two CSV files in that folder, Tableau has done a really neat thing. It has loaded both of them in together, saying, oh, you probably want everything that's a similar format that's in this folder. I'll bring that in for you. We're really happy for that. That's actually really helpful. So we're going to do two types of joins here. The first is going to be an inner join. And the second is going to be a full outer join. Now, knowing that the total population is an annual number, whereas the period indicators is an every 5 years number, what do you expect the effect to be if we do an inner join? I'll give you a second to think about it. All right. If you said that all of the years except for the overlapping years were dropped, then you're correct. Let's look at what that looks like. So let's go the period indicators and we will do a join. We'll do an inner join, and we see that it looks like it worked, but there's nothing happening here. What's going on is that the data sets are really big, so we will click Update now. And if we take a look at these data sets, and we kind of scroll over quite a bit, we can see that the year 1954 was repeated very many times. This is not actually what we wanted. We probably more likely just wanted the 5-year record, so like 1950 to 1951 or 1955, to be joined to something like, I don't know, 1953, the year in the middle. We can try to do that here by making another row. And we'll say add new join clause, and we'll say time for the year, because from those 5-year spans, we want to get 1953, and our total population by sex has individual years. And over here, we'll use the mid-year, the mid-period. Now, this gave us this big red exclamation point, which is exactly what we would have expected. And what that tells us is that these two are not the same data type. If we go here and look at the mid-period, we see that it's we go here and look at the time, we see that it's a whole number. If we go over here and look at the mid-period, wherever that is, we see it's a decimal number. Now, we are going to go to the time and change it to a decimal, rather than changing the decimal to a whole number. The reason being that it causes a rounding error and your join won't work. But if we do it this way, then our join works perfectly. And see, we have each year repeated only one time, joined to the ranges over here. So this is actually how we wanted our join to work. We have, 1950 to 1955, the mid-period is 1953, and this is joined to the 1953 data point from the population table. All right, so we're going to go over to our worksheet, and we're going to make a visualization of the net migration for each continent for each time period since the start of data collection. All right, we're going to do this in small multiples, and we're going to break apart the continents. More realistically, you would probably do this with a subset of countries, but since we don't really have a research question that's guiding us other than a broad investigation into changes in migration, this is really just experimental. In a more fully developed project, what you would probably do is look at all of the different countries and see if there's any kind of an interesting pattern, or just kind of explore what the overall trend tends to be. All right, so we want to draw our time pill up to the columns because we want our time to end up being on our x-axis. All right, we are going to drag our location, because we need our location names, to the rows. This gives us a table, and this table basically has no information on it whatsoever. If we did just want a table of information, we could put information on the tooltip or something like that. You very rarely want that. I'm going to go down here to the measures and pull over the net migration. And net migration is a measure of the number of people who have arrived in versus the number of people who have left a particular country or region. Now, this would be far more interesting if you wanted to compare two countries, such as the United States and China, which maybe we should do that. Maybe we could pick, 5 very large countries and compare that rather than continents. Okay, so we're going to change our research question slightly. We're going to look at the United States, China, India, Brazil, and Russia, in large part because they are often referred to as the BRIC countries and are emerging economic powerhouses. All right, what we're looking at right now is every single data point in this data set, which is just not very easy to understand. What we need to do is filter our data. So we're going to go here to location, and we're going to click on the little arrow, and then we're going to select filter. And we have all of the countries selected, including the continents and the world. We are going to select none, and then we are going to search for the 4 countries that we're interested in, which are the United States, China, India, Brazil, and Russia. All right, and we'll apply that, click OK, and then we have just those 4 countries alphabetically ordered. Now, alphabetical ordering might not be the most useful thing for us, so we probably want to order them a different way. If we go up here and click on location, or if you go to the pill and click on the down arrow, then we get this sort option. Let's go ahead and click on sort, and we're going to sort by a field. And we're not, well, yeah, let's sort on net migrations, because that's what this visualization is actually about. So we'll sort on the net migrations, we'll apply, click OK, and what we see is that overall, India has the smallest net migration. That might not be how we want to visualize it. Let's say that we wanted the United States on the top because we wanted to know the people that were coming in as opposed to the people who are going out. All I did here was I clicked on it again, but you notice that I've lost my sorting, that it's now sorted alphabetically and not based on migration. So we come here again, we go back to our sort, we click on a field, aggregation is the sum, and we will sort by descending. Apply, click OK. And here we have, for each time frame, the net migration in each region. And this helps us see overall the trends. We see that Russia lost people and then it gained people, and it really gained people in the 90s and the 2000s for all kinds of geopolitical reasons, and then has been pretty consistent since then. Same with India. It gained people in the 70s, but has lost people pretty consistently since then. But the United States has had a trend of gaining people with some real peaks here around 1995, which has to do with changes in immigration law. Okay. If this were a full visualization, we'd change the title, we'd change the headers here, and work with this a little bit. You know how to do all of that. You know how to edit your tooltips. You may decide that you want to reformat your labels down here. The way to do that is to right-click on just one of them. By right-clicking, you get this format pane, and then you can come over here to format. You can change the alignment a little bit. You can change the direction like that. You can change whether it wraps or not and specify all of these things pretty easily. There's a bunch of formatting things here about line widths and borders and shading. So go ahead and play around with this a little bit until it gets to a point where you feel comfortable with it. And then go ahead and publish this visualization to your Tableau public. Feel free to, do things like add migrations to the colors marks card here and see how that changes the visualization overall. All right. I hope that you have enjoyed the data structures and DataJoins tutorials, and I look forward to seeing you in the next lab. All right, bye-bye.